Hello and welcome to this video on the Uniform Plumbing Code. We're going to be looking at Section 904 dealing with vent sizing, specifically the aggregate venting requirement. Section 904 deals with vent sizing, and a bit of a review. The size of a vent within the Uniform Plumbing Code can be somewhat complicated. A number of factors influence the size of a vent, which includes the length, the total number of fixture units, also a minimum vent size of 1.25 inches. Size has to be at least half the diameter of the drain. Also, the fixture being vented will influence the vent size. Now, in addition to this, the drainage piping of each building, of each connection to a public sewer or a connection to a private sewage disposal system, that connection needs to be vented by means of one or more vent pipes. So the aggregate cross-sectional area then of that venting, which is venting that sewer, has to be at least the area of the minimum sewer size which is required. When we're doing our sizing calculations, there's a number of vent pipes which are not included in that calculation to vent that connection to the public sewer, which include vents which are upstream from pumps, ejectors, backwater valves, or other obstructions. So we'll focus in on our vent sizing specifically now as it relates to calculating and applying the cross-sectional area requirement. We begin by considering the simple diagram of a one-bathroom house where we have a water closet, lavatory, a bathtub, a kitchen sink, and a washing machine. Using our charts from Chapter 7, we understand that we have a 3-inch building drain requirement. Let's apply the minimum vent sizes now to each of our vents. And in this diagram, we're going to be venting each one of these fixtures individually through the roof. Water closet require a 2-inch vent. Lavatory 1.25-inch vent. The tub, the kitchen sink, and the washing machine would each require an 1.5-inch vent. Now, there's a number of pipe sizes that we've been dealing with. We deal with 1.25 inch, with 1.5 inch, 2-inch, and 3-inch in our diagram. We've also been dealing with the concept of our area. So the area of each one of these pipes is going to be equal to pi times the radius of that pipe squared. And if you don't want to do the mathematical calculations, in the back of the Uniform Plumbing Code, there is a chart of useful tables, a series of charts, and one of them includes areas of circles. So 1.25 inch has a cross-sectional area of 1.23 inches squared. 1.5 inch, 1.77. 2-inch, 3.14. 7 inches, 7.07. So we now have to understand what our building drain is, and there's an asterisk there because that's also going to be the minimum sewer size. We can oversize the sewer, but we cannot undersize it. And the cross-sectional area is 7.07. Now that's significant now because when we go and we add up all the values of all these vents now that are going up through the roof, that has to be equal to or greater than the area of our minimum sewer size requirement. So you add up all of those values there of those vents coming up through the roof, it has to be equal to or greater than 7.07. That's in accordance with Uniform Plumbing Code Section 904. So let's calculate what our cross-sectional area is. We have tub vent at 1.77, our kitchen sink and our wash machine vent are each 1.5 inches, but they only count between the two of them for 3.14 inches. And we'll explain that why later. Lavatory vent 1.23 and the water closet vent 3.14. We add all of that up together and we come up with 9.27. So here's the question. Why do we only get 3.14 between those two values? To answer that question, we would need to turn our attention to the Uniform Plumbing Code Illustrated Training Manual, which says the cross-sectional area of each vent must be conveyed through the drainage pipe of at least the same areas as the cumulated aggregate total. In this example, we have an 1.5 inch pipe with 2.5 inch vents coming off of it, and those 2.5 inch vents go to a 2-inch vent. But the cross-sectional area value of this 2-inch is equivalent to the drain pipe, which is 1.5 inches. In this example here, that 2-inch vent has the equivalent value of the 1.5 inch drain pipe to which it is connected. Another way of expressing this, if you had a 2-inch drain pipe and there was 2 fixtures associated with it, in this example we have a wash machine and a sink of some sort, and each one of those is vented directly to the roof, you might think that you would have equivalent area of 3.54 when you add up the 2.5 inch vents. However, it is connected with a 2-inch drain pipe. So the cumulative area of those 2.5 inch drain pipe or vent pipes, so the cumulative area of those 2.5 inch vents is equivalent to the 2-inch drain pipe, which is 3.14. The equivalent vented area of those 2 fixtures is equal to the cross-sectional area of the drain pipe, which is common to those 2 fixtures. And in this example, we have a total area of 9.27 inches, which of course is greater than your 7.07, and so this would have adequate venting. However, this example is somewhat unrealistic because we don't normally have individual vents going through the roof for each fixture. It's much more common for us to combine vents. It's also much more efficient. So let's combine some vents together. We've combined the wash machine and the kitchen sink vent. We've also combined the water closet vent and the lavatory vent. Let's do our vent calculation now, and we can see that with our vent calculations as it is right now, that the total aggregate area is 6.68, which is less than our required 7.07, and so this arrangement would not be acceptable. We're going to have to reconfigure our venting somehow or another. The simplest way to do that would be to increase the vent size of the common vent between the wash machine and the kitchen sink to a 2-inch, and then we recalculate it, and we can see then that it is 8.05, which is going to meet our minimum requirements. There's a variety of configurations that would work within these situations, and you may very well need to go and try a few different configurations before you land on one that works. Now let's go into a much more complicated example. In this system, we have a sewage pump. This presents a special problem in a couple of different ways, not the least of which is that a sewage pump, which is connected to a water closet, has to have a minimum capacity of not less than 20 gallons per minute. In this example, we have a bathroom in the downstairs, which is pumping up to the building drain. This presents a problem because the flow rate of that pump, which is a minimum of 20 gallons per minute, is 2 fixture units per gallon according to 703.2. This presents a minimum of 40 drainage fixture units just on the pump discharge. What this will do then is it requires the building drain to have a minimum size of 4-inch. Also, we're not allowed to calculate or use in our calculation any of the vents associated with any of those fixtures which are upstream of that pumping station. So the required minimum venting for this system of a 4-inch pipe is 12.56 square inches. So when we look at those 3 vents now that are coming up through the roof, those 3 vents somehow or another have to equal or exceed 12.5 inches, 12.56 square inches. So let's go through the first trial and let's put our minimum vent size for each of these vents. 2-inch for the upstairs bathroom, 1.5 for the kitchen sink and laundry, and then 2-inch for the main floor bathroom. We calculate all that up, 1.5, 1 2-inch, 1 2-inch, and that's a total of 8.05 square inches, which of course is less than the required 12.56. So how could we resolve this? Well, first thing we would try is increasing the vent size for the main floor water closet from 2-inch to 3-inch. Increasing that vent size to 3-inch, and then we recalculate our totals, and our total is 11.98, and we're still not quite close enough. So we would need to adjust yet another vent. Let's try adjusting this vent, which is our kitchen sink or wash machine vent. Upsize that to 2-inch. And then we would recalculate our values. And in this arrangements, we have a total cross-sectional area coming through the roof, 13.35 inches, and that is acceptable. Okay, so with that concludes this video regarding Section 904.1, Aggregate Venting Requirements.